guys! Mayong adlaw. Welcome to NatzMath TV. So for today's video is the continuation about the laws of exponents. So we have here the law on power of a fraction, which states that for every real number a over b quantity raised to m, where m is a positive real number, is just equal to a raised to m over b raised to m. And we have to take note that our b should not be equal to 0. Why? Because this would make the whole fraction undefined. So how do we simplify expressions using the law on power of a fraction? So we will try these examples here. We will have example number 1. For example, we have x over y quantity raised to 2. So by applying the law on power of a fraction, we just simply multiply the exponents of both the numerator and the denominator. So in this case, since we have here x over y, and it is assumed to have an exponent 1, so therefore, we just simply copy the numerator and denominator and multiply the exponents. So we have here x raised to 1 and y raised to 1. So therefore, what we need to do here is just simply copy our numerator x and multiply the exponent of the numerator. In this case, our exponent here is 1 multiplied to the outer exponent, which is 2. So therefore, this is x squared. That's over. The same thing happens in the denominator. So we have here y. We copy the base y. And it has an assumed exponent 1 multiplied to the outer exponent, which is 2. So this shall become y squared. So therefore, this is now our answer. Next example, we have here 2 over c squared quantity cube. So our numerator is 2 and our denominator is c squared. And since our numerator is constant, which is 2, it has an assumed exponent 1. So therefore, this shall become 2. We copy the base 2. It has an assumed exponent 1. So we multiply 1 times the outer exponent, which is 3. So this shall become 2 cubed. And that's over. We have the c squared. So we copy c and we multiply 2 times 3. That is 6. So we have here 6. So this is now our answer. Next example, we have a squared b over c d cubed quantity raised to 2. So this time, we will do this one by one per variable. So we have a squared. So we have a squared. We copy the base a and we multiply the exponent 2 times 2, which is 4. Then the second variable, which is b, it has an assumed exponent 1, so 1 times 2 is 2. That's over. The same happens for the denominator. C, it has an assumed exponent 1, so we have c. C raised to 1 times 2 is 2. And of course, the d, we have d. We have 3 times 2, which is 6. So, this is now our final answer. Next example, 3m squared over n cubed quantity raised to 4. So in this case, we have 3. Again, it has an assumed exponent 1. Then we multiply the exponent here to the outer exponent. So our base here is 3. Then we have 1 assumed exponent 1 here times the exponent here, which is 4. So that is 3 raised to 4. Then for the variable m, we copy m. Then we multiply 2 times 4, that is 8. Then that's over. We copy the variable n. Then 3 times 4 is 12. Now, is this not the final answer? No, because we still have 3 raised to 4. We need to simplify the constant 3 raised to 4 by multiplying 3 4 times. That means 3 times 3, which is 9. 9 times 3, which is 27. And 27 times 3 is 81. So therefore, 3 raised to 4 is 81. So our final answer would be 81 m raised to 8 over n raised to 12. So this is now our final answer. Now for this next example, we have 5 over 2p squared quantity raised to 2. Again, Our numerator is 5. Again, it has an assumed exponent 1. So we copy 5. Then we multiply 1 times 2, that is 2. So that is 5 squared. Then 2p squared, we have here the constant 2. Again, it has an assumed exponent 1. So that becomes 2 squared. That means we have assume 1 here, multiplied to 2, this is 2. Then our p squared, so we copy the p, and we multiply the exponent 2 times 2, that is 4. Then we simplify further, since 5 squared and 2 squared can still be simplified because they are constants. So we simplify 5 squared, that means 5 times 5, so therefore this is 25. That's over 2 squared, that means 2 times 2, which is 4. And we copy p raised to 4. So our final answer would be 25 over 4p raised to 4. Next example, we have 2a over 3b squared. The same process. We have 2, so we copy 2. Then 1 times 3 is 3. Then we copy a. Again, a has an assumed exponent 1, so 1 times 3 is 3. That's over. The same also with the 3 in the denominator. So we have 3 raised to 3 because of this 1 times 3. Then we have the b squared, so we copy b. Then b times 3, that is 6. Then simplify the constant. We have 2 cubed, that is 2 times 2 times 2, which is equal to 8. So 2 cubed is equal to 8. We copy the variable a cubed over 3 cubed is 3 times 3 times 3, which is 27. Then we copy the variable b raised to 6. So this is now our final answer. Next example, we have here negative x over 4 quantity raised to 2. So as you have observed, we have the sign here negative. And since it is raised to 2, that means negative raised to 2, that means negative times negative. So if we are going to raise a negative number to square or to 2, that means the result would be positive. That means negative times negative is positive. We have x squared. We copy the variable x. Then we multiply the exponent. So that is x squared over. We have 4. We have the exponent 1 times 2 is 2. Now, as you can see, as I've said earlier, since this is negative raised to 2, the result would be positive. That's why we no longer have negative sign here because the result is already positive. Then we simplify the denominator here. We copy the numerator x squared over 4 squared is 16. So therefore, our final answer is x squared over 16. Next example, a squared bc over mn squared quantity cubed. The same process. We multiply the exponents. We have a. 2 times 3 is 6. We have b. 1 times 3 is 3. Same process with c. That is 3. Over m. We copy m. Then we have assume 1 here times 3, that is 3. And n squared, so we copy n, then we multiply the exponent 2 times 3, that is 6. So since we can no longer simplify the variables, since we do not have a constant here, so this is now our final answer. So this is how we simplify expressions using power of a fraction. So that's it. I hope you have learned something from this video. I still have other videos here, so just click these videos, watch these videos related to this topic. So for now, thank you and God bless.